Go ahead, please.
A very good afternoon to all the esteemed dignitaries on and off the dais, senior scientists, esteemed faculty members who have joined us in both online as well as offline mode, and everyone present here today. At the outset, it is my great privilege to extend a warm welcome to our esteemed guests from LOHUM Cleantech Private Limited, Mr. Pratyush Sinha, who is the Vice President Special Projects from LOHUM Industries, and with him we have Dr. Chidambaram Mandan, who is the Vice President and Head of R&D, Quality Control and Sampling at LOHUM Industries. To begin the program, I would like to request Dr. A.K. Singh sir to kindly welcome Mr. Pratyush Singh sir with a Tulsi sapling. I would like to request Dr. Neeraj Sharma sir to kindly welcome Dr. Chidambaram Mandan sir with the Tulsi sapling. Yes, sir.
Thank you.
We welcome you at our campus, sir. LOHUM Cleantech Private Limited, founded in 2018 and headquartered in Greater Noida, India, is a pioneering climate tech company specializing in sustainable lithium-ion battery life cycle management. The company focuses on recycling, repurposing, and low-carbon refining of battery materials to support a circular economy in the energy sector. LOHUM's mission is to become the world's largest producer of sustainable battery and energy transition raw materials, contributing to a greener and more sustainable future. We firmly believe that by combining LOHUM's practical industry solutions with Amity University's academic research, such a partnership can significantly contribute to the objectives of the National Critical Mineral Mission, promoting sustainable practices and technological advancements in India's energy sector. Without further ado, I would like to request Dr. A.K. Singh sir, Senior Vice President, Amity Foundation for Science, Technology, Innovation Alliances, to kindly deliver the welcome address, followed by a brief presentation on Amity Research Ecosystem. Please, sir.
Okay, good afternoon, everyone. Honorable Founder President, Honorable Chancellor, and Mr. Pratyush Sinha, Vice President, Special Projects, Dr. Chidambaram Mandan, Vice President, R&D Materials, Dr. Neeraj Sharma, Dr. Murthy, Group Captain Shukla, all the senior faculty members, those who are online or sitting physically here. I think we are delighted to have both of you with us this afternoon. And on behalf of the Honorable Founder President and on behalf of the whole Amity Education Group, I welcome you. And LOHUM Cleantech Private Limited, which we feel is one of the pioneer industry progressing on a fast track to reach to the pinnacle. As my colleague told that you are in the business of critical minerals and almost you are taking care of the either manufacturing, reuse, second life solution, recycling, I think, which is emerging as one of the most important aspects in the Indian context. When we say lithium, now people have started saying lithium is also the white gold. And the critical minerals are really becoming critical. And as Government of India has shortlisted 30 number, though the number varies from country to country. And that has become essential for transitioning to a greener future. And if we really see that critical minerals are required on many sectors, I think it goes much beyond renewable energy. either photovoltaic or other semiconductors, wind turbine, healthcare. I want to highlight healthcare. Let me share with you when you talk of molybdenum, rhenium, strontium, because molybdenum, which is the mother of technetium 99M, which is the workhorse of all nuclear medicine departments, its availability is a very critical issue. And for therapy, strontium and indium, these are very important. So the things are going much beyond what generally we talk. And coming to the defense, I think we have seen this time the criticality. I think all the weapon systems which were used in this recent conflict, I think critical minerals had played a critical positive role. And the time has come when we cannot, defy or we can ignore the importance of their sustained availability at our will in India. And if we see the projections, the way according to the International Energy Agency, by 2030, they say it will become thrice. And the main thing is by 2040, it will become 4 times. It means in 10 years, it will go about 25%. Don't go into the real, maybe but less than 25%. And this ownership, the availability of these critical minerals is so skewed that I think 40% of the total average minerals, they are available with China. So I think the time has come that we should take care of that. We should be cognizant of this issue. And I'm sure that government is, not only by talking, by actions. As all we know, in 2024 budget session, Honorable Minister announced the National Critical Minerals Mission. And in January 2025, I think it has started. We are very much aware of it. And Harjinder Kaur and her team is in touch with the ministry to seek their guidance and to understand what are their plans so that we can also participate in this journey. And we are doing some research in this, as already that we are running a project of Ministry of Mines with your partnership. And yesterday, when this team came back, just an idea, they went. They're the S&T warriors. One of their colleagues, Parul Singh, she said, why can't we have indicator plants? Bioaccumulators. So then she had sent me a note in the evening. So that was a very fascinating note. And it was very encouraging that these people are not just visiting them, they're also applying their mind. Can we find some solution? Because something to do with the bioremediation. So now I'll say another idea which ministry has floated is COEs. Why I'm flagging this? If not today, but we need to start working so that at an appropriate time, we are able to establish the COEs, which in their format, they say it is going to be spoke and hub model. So we will also keep a deep eye on this aspect. And when I had been talking of industry, I had been talking of ministry, but I think one of the most important aspect in this tripod is the higher education institutions. Because they are the source. कहते हैं जो स्रोत है जहां से हर चीज उगेगी या निकलेगी वो higher education institutions हैं. So they have got a very important and again for the critical minerals critical role, either in terms of R&D, in terms of ideation, in terms of validation, even in terms of availability of trained manpower, or in terms of, when I say R&D in all the aspects, whether separation, metallurgy, mining, or mining, and then recycling, etc., etc. So these are the some thoughts which I thought I'll share with you. And LOHUM is not new, and they had already shown their gesture that they are interested in business and they want to support the universities. Thank you very much for supporting that project. We are really indebted by you. Now, in next 10 to 15 minutes, I'll try to just give you the glimpse of the MIT universe. That what do we do, why we are here, how we do, and what are our expansion plans. And after that, I think I'll request you to share your thoughts. I think welcome again. I think we have failed in putting a good picture of Pratyush. He looks much more smarter than the photograph. We are sorry for that. Okay, we again welcome you. Now, the MIT education group, it is one of the largest education group in this country and one of the most happening place also. And we boast of saying that we have more than 700,000 alumni spread across the world and, doing their job or, furthering their skills and contributions in their respective domains. And we have about 300, a bit less than 300,000 students who are actively enrolled in various campuses. We have 6,000 faculty, regular faculty and scientists, and about equal number adjunct faculty and the visiting faculty. We have 12 universities spread across states in India and similar number around the globe. And at MIT, we offer or we impart education right from kindergarten to postdoctoral, or that is what we say post PhD. And recently, we have got one of the big brands in school, that is Harrow School, which is functional in Bengaluru. And in the other aspect, I'll say that we have got reasonably very strong and huge civil infrastructure and technical infrastructure. Just to give you the glimpse where is our presence, Manesar, Haryana, Noida and Lucknow and Greater Noida, they are in Uttar Pradesh, Bihar, Patna, Jharkhand, Ranchi, Kolkata, Raipur, Bengaluru, Mumbai, and Madhya Pradesh, Gwalior, and Rajasthan, Jaipur. And if we talk of abroad, I think right from Singapore, Nairobi, Tashkent, London, Dubai, and New York, and we have two campuses in US. One is in San Francisco, and other is in the Long Island, where the thinking of Honorable Founder President is that we want to make it the traditional medicine global research hub. And the programs, इसमें वो फाउंडर की फोटो कहाँ है? Okay. इसमें programs which we offer, and these programs are basically driven by the employability. If you get the employment, then these programs are offered and they are sustained. And we have a huge canvas right from social science to engineering science, biological science, chemical science, arts and culture, and agriculture, and defense technology, nuclear science, neurophysiology, pharmacy. You think of any program we offer in one or the other campuses. And when we talk of the NIRF ranking, we have not seen, more than 50. We have always been in the top 32. Either it is in the University 32, and we are also accredited by one or almost all accrediting agencies at national level or global level. Just to share with you, we are Asia's university not for profit by US regional accreditation. And this agency accredits the top universities, and that gives us the leverage or advantage of aligning our curriculum to the global level and also maintain the quality. And what I had been telling you, that is nothing but the vision of the creator of this whole universe, that is Dr. Ashok K. Chauhan, whom we call the founder president. And he himself is an chemical engineer and who went to Germany, and he was a flourishing businessman in Germany. He had a huge business there. And then he decided to do some philanthropy. created the MIT Education Foundation, came back with the idea that he wants to combine or amalgamate the sanskar and ethics of the East and the latest technology or the other aspects of West, so that he can contribute in the development of India to make India the developed country through education. And the photograph which you see, the Atul Chauhan, who is his eldest son, he's chancellor of this campus and other campuses, and he's a product of London School of Economics. Dr. Asim Chauhan is younger son, who's also chancellor of other campuses, and he's a product of Wharton Business School. Ajit Chauhan, Abhay Chauhan, and Amol Chauhan, they take care of various aspects like, online, MIT online, or strategy, and other things. And Amol Chauhan is the product of Harvard Business School. So all his sons have affiliation with the best of the global educational institution, means an educated family is driving the education. So that the point which I want to drive is this.
All five of them are founders.
Yes, all five. Now, since you have raised this question, not only five, each and every family member of Dr. Chauhan is contributing. I think what we hear from Honorable Founder President that they have to contribute. Understood? They have to. So a very disciplined joint family and lot to learn from them. Now, the tagline of MIT is it's a research and innovation driven university. So I was thinking, because I had been in DRDO and a researcher myself. So when you have to do something, there has to be a political will. Because Americans decided that we want to put man in space. It was the political will, and they did it. Recently, we saw it was the political will that we have to show to the world that we don't tolerate terrorism. Political will was there, we demonstrated. So here for research and innovation, there is a will. I think will of the trustees, that is ample. They always promote that we should be research and innovation driven. And after that, the functionaries, the management, means deans, HOIs, then vice chancellors, pro vice chancellors, their job is to facilitate. It should be the ease of doing research should be there. Infrastructure, I told you we have enviable technical and civil infrastructure. Human resource, which is the differentiator, which is the main aspect. We combine the experienced people from India and abroad, and the young, energetic people. And that experiment had been very successful. And we have various enabling processes and mechanisms to create a research ecosystem and act as facilitator. And collaborations and industry connect, I think you can't do without it in this time. And we are trying to connect with you, and that is part of that. I will be a bit fast. Then IPR cell, we are very much conscious about IPR, and we have a very good IPR portfolio, which I'll share with you. We have dedicated Directorate of Innovation and Technology Transfer sponsored by DST. And at one point of time, Dr. Neeraj Sharma was instrumental in that. Now he's also mentoring at the moment. Entrepreneurship development, we try to create the entrepreneurial mind right in the beginning. And we have FST and STIF. These are the two foundations from where I come. Dr. Neeraj Sharma comes. Our job is to facilitate, to support, to mentor, to connect. That is our job, so that the faculty members are able to do their research at higher level, with a higher speed, and with least leg work. And we have MIT Directorate for Science and EDC also. And founder president gives, throws challenges. What we say, the success by compulsion through various missions, mission outcome. We have with us the chief of mission outcome, Group Captain Shukla. Now he is here, he is watching. Then at the end of the day, he will say, what is the outcome? So we what is the outcome and what we want to do. mission connect and synergy. And I'll just share with you the latest missions, mission space that has been, started about 1 year back, where the aim is that Amity should be the #1 space science partner with ISRO. Means we should be the #1 space science university. And for that, it is not the tagline. We have signed MOU with the ISRO, and we are doing a lot of research with them. I'll share some of the research with you. Mission Green Hydrogen is similar. And here also, there are many industries who are in touch with us, and they are funding our research at MIT University. Quickly, I think we connect with the senior people abroad, the Nobel laureate through, research seminars, student exchange or their supervision. And also we connect with a lot of, senior faculty members from India. With Dr. B.N. Malik, you would appreciate, he's a Bhatnagar awardee. Dr. B.C. Das, who is the father of HPV, human papillomavirus. And Ajit Verma, and P.V. Sharma, who had been Vice Chancellor of 3-4 universities, Dr. Silvamurthy, and other senior people. And another signature activity of MIT is that Ramalinga and Ramanujam Fellow. The people who go abroad after PhD for postdoctoral fellowship and where they want to come back. So government has created 2 fellowships by DST Ramanujan and DBT Ramalinga. And that is a competitive fellowship that is just to, smooth transitioning. And it's a competitive. And they have to choose the host where they would like to pursue their fellowship. Let me share with you with the pride that we host the maximum number of Ramanujan and Ramalinga fellows in this country. And that shows that our, speaks a lot of our credibility and the trust which fellows show in us. And we do not leave them once they complete their fellowship. They are offered the faculty positions, and we have about 12 such fellows who are pursuing their research with independent teams. I think I have already talked, we have almost all the facilities available to carry out plant research, tissue culture, animal tissue culture, analytical work. And we have almost all instruments, either all spectroscopy, all chromatography, all microscopy, right, fermenter. And we have various, schemes, funded schemes for instruments in various campuses, and we combine and leverage the technical facility for our research. Or otherwise, we also have MOUs with other institutes to use their equipment. Recently, the management has created an artificial intelligence center for excellence by creating a 10 petaflop computing capability. And this is a common facility which is being used by management people, law people, science, means biological science, or even the physical science people. These are the research priority areas which we pursue at MIT. And I think because today, I'll just give you the glimpse. But cancer biology is a huge group, and where we are pursuing almost all the aspects of cancer biology, right from detection, diagnosis, prognosis, creating new models, finding out new targets, new molecules, and understanding the pathophysiology, and working out various new modalities for therapy. So we take care of that, right from stem cells to regenerative medicine. And we are also working in molecular medicine, precision medicine. Neurosciences is a huge group where we mainly focus on developmental neurosciences led by the Bhatnagar awardee, drug targeting, drug repurposing, click chemistry. I think that is relevant to today's discussion. This is a unique department which has been created under the mentorship of one of the Nobel laureate, Dr. Moses. There, they use this click chemistry concept for creating new molecules, and which are used for various applications. And we have with us Dr. Saika Datta. He will comment at an appropriate time on this. We are part of CRN CMS project, agriculture biotechnology. Here we take care of, or we do research in almost all aspects, either soil health, plant health, disease resistance, productivity, environment, fortification, and to the extension activities. And this group is led by Dr. Nutan Kaushik, or agriculture biotechnology. Environmental research, we are very much bothered about the environmental health, be it water, be it air. And we have a small, weather monitoring or air quality monitoring setup under the aegis of IIT Delhi and NASA, where we keep recording the various parameters, air parameters. I think some of the specific sustainable technologies, Rutonic, it is the Piriformospora indica, which is the root endophyte. The beauty of this product is that we have transferred this technology to 9 industries, and one is in Taiwan, and the product is available. It takes care of the abiotic stress and act as a biofertilizer. And I think agri-photovoltaic, it is just to enhance the income of the farmers through photovoltaic, and the electricity so generated is used in the farm, or surplus is fed into the grid. In materials, we work on many aspects of materials, phase change material, and then we use these materials for various applications, for various sensors, be it for gas detection or be it for biological parameter detection. We also work, sorry for the spelling, nanotechnology, various nano-based sensors. We work in this. And recently, I told you the MIT's Green Hydrogen Mission, where we have 2 Ramanujan fellows working in green hydrogen, and we have 1 fellow being deployed by Ulu University. And they are spending a lot of money, and we are working on a whole life cycle, right? For production, storage, safety, then its application aspect. Defense technologies, we are one of the pioneers in starting the BTech and MTech in defense technology under the mentorship of DRDO. And we run a lot of DRDO run projects like Divya Drishti, which has been successfully completed in the personal identification through gait, physiological and anatomical parameters, even when the face is occluded. And that has been successfully submitted. And now we have been given another project in sequel where we want to understand the fidelity of the underwater welding through AI. So there are other projects you can, I think, read that. And another project which has been given to MIT by DATRA, Defense Threat Reduction Agency. It's a very important agency of Department of Defense, US. They have given a project of more than 1 million, where we are developing various modalities and algorithms, how we can take care of our civil nuclear assets. And you all know this nuclear asset is again drawing attention of the world. The space science and technology, which I said, that many of our campuses work on space science and technology, astrobiology. There's a big group in our MIT University, Mumbai. And recently, they have sent a plant callus of spinach in space with ISRO. And they get the information about its growth, root, and other ingredients, other nutrients. Till now, the things are going fine. We also do the image processing of the data which we get from ISRO. Then debris management, we have a MIT Institute of Space Science Technology here, which is headed by one of the former DRDO scientists, Mr. Dr. M.S. Prasad and Dr. Shivani Verma. They work on this radar-based disaster forecasting, CubeSat aerial aircraft, which we are planning to send a CubeSat with ISRO in times to come. And we also have a MIT Dubai satellite ground station, where we track satellites, predict weather and pollution based on the data which we receive. बहुत जल्दी 2 मिनट ले रहा हूँ, बस 2 मिनट. I have been told that finish quickly. MIT is so huge, it's very difficult to conclude so quickly. And we have one of the best DST sponsored MIT incubation center. If time permits, we will take you there. MIT incubation incubator. And if you see, there are many graduated incubators who have already gone out, resident incubators and virtual incubators, startup ecosystem. We have about 300 student startups, and now we are pushing for the faculty startup. The Shivani Verma, who owns a startup, she is director of that startup and also the professor in space. And another startup is being floated by one of the faculty, Dr. Ranu Nair. She has developed a membrane for specific absorption of the oil spillage. And that can be reused about 100 times. The USP is that. I think we offer these courses in defense technology. And now coming to the publications. And this is our, sustained growth, how we are, publishing with ever accelerating speed. And I had told you so many things, but I will share with you the barometer is the numbers, that how do we substantiate. Now we have about 45,000 publications in Scopus and non-Scopus journals. And as I told you, our IPR portfolio, we have filed 2,396 patents, 430 have been granted, 35 technologies have been transferred, and the average H index of faculty today, when I say today, is 178. Tomorrow it may be 177. Tomorrow it may increase. And we have been amply appreciated and rewarded by various agencies, government, non-government, on our IPR. This is the top academic institution award, which was given by Dr. Piyush Goyal in 2020. We got special award in 2022. Questel IP Excellence Award we got in 2022. And we got the CIA Industrial Intellectual Award in 2023 and 24. And recently, we have got as the SHM 4th Excellence Award for Best University with a Strong IP Ecosystem. And we not only are into the education, we are also concerned about the society through two foundations, Amitasha and Atulasha. We provide education to underprivileged, women empowerment, and livelihood generation, and research and impact evaluation. I think since you are here, then we also work that who are the institutions who we thought can directly work with you, So these are the some, their representatives are here, either online or offline. They will be sharing with you their thoughts, and let's see what we do. And I think today's the agenda is that we are already in touch with you. So let's see how we can foster further, how can further strengthen, not only on the Y scale, we also want to go on the X scale. So that we also expanded. I think with this, I'll stop here. And if Harjinder permits, thoda sa as a let me introduce our guest. 1 minute. I think Mr. Pratyush Sinha, I think thank you very much. I think one sentence is more than enough to just introduce him, that he is an alumnus of IIT Kanpur, from where he did his BTech in electrical engineering and MTech in electrical engineering. Right? Yeah. And he is the VP of the special projects. When LOHUM and co-founded Merak.ai in 2018 and held multiple roles there as co-founder. This had been his another task, primarily focused on building human-in-loop ML system. And Pratish also, developed image processing, algorithms, and handwritten text recognition, deep learning models. Additionally, they manage the sales process, recruitment, and learning models. Led the product through iterations prior to Merak.ai. Pratish worked as a machine learning engineer at AlgoVision from March 17 to 2018, and their earliest work experience was as an associate product manager at Hike Messenger from July 14 to July 16. Wide experience. It looks that you are an AI person. Am I right? And that yesterday there was an article that India is going to be the global supplier of AI experts. And Chidambaram, as me and Dr. Neeraj Sharma and Murthy were talking, he is a very varied experienced hardcore researcher, a chemical scientist who did his PhD from National Chemical Laboratory, Pune, PhD from Israel, Hebrew University, and also University of California, Berkeley, I think one of the top institutions. His biodata is very, very long, and he has worked in CAT, STL technology, and that has earned him recognition, and not only recognition, that had been his game-changing changer award, where he worked out, and commercialized over 65 precious metal-based catalysts. Currently, Dr. Madan serves as Vice President Head R&D Quality Control at LOHUM, and he has 26 international peer-reviewed publications, 46 patent applications, and one of his patents, that is mercury removal from flea gas, was commercialized. I think here is a man researcher whose product has been commercialized, and he had been the member and still member of many committees, NIT Bhopal, Board of Studies, and some DST, American Institute of Chemical Sciences. I think very long. And after that, he loves science fiction and cultural novels, playing badminton, and following politics. I think nothing is left which you are not doing. Thank you very much once again for being with us. Now, I think we will request Dr. Pratyush and Dr. Chidambaram to share about LOHUM and your thoughts on today's visit.
Clinical code
What I will do is I will briefly introduce me and the company. And then around the R&D point, I would like Dr. Chidambaram to come in and talk about the different R&D initiatives. And we have not brought a formal list of all the open R&D problems, but we can talk about them and then see if there are any that where we can work together with Amity University. So as a company, LOHUM, our goal is to become the world's largest producer of sustainable critical materials. That is the goal. Critical materials, as you might know, is a very large global market, $800 billion of market. Almost 40% of the global GDP is dependent on it in one way or the other. And most of the refining capacity for all of this today is concentrated in China. So what we are trying to do is basically bring that capability and know-how into India and then scale that up. All these minerals are used in across various different kinds of applications, where that's EVs or batteries, defense, aerospace, medicine, and whatnot. So that's the idea now. And we've seen how China has basically captured this market overall, and how the rest of the world is now trying to play catch up. And that is where we would like to come in. Just from a global policy landscape, that all the different countries in the world have basically come up with their own set of regulations around it. India has also come up with its National Critical Minerals Mission, where the target is to acquire 50 mines globally, have 1,200 different projects around critical minerals in the country. And then there are different global partnerships that we are looking at. Now, in terms of what we do at LOHUM, so our focus is on currently three different categories of materials. It's not captured over here. The first is battery materials, which includes lithium, nickel, cobalt, and graphite and their derivatives. The second is platinum group of metals, and the third is rare earth elements. In each of the cases, the idea is that we want to develop the capability to refine the material, produce the metals or salts, which can be sold as commodities. And the key problem statement we work on is to do this with the lowest cost and with the highest yield. So that is the base technology. And then we want to integrate vertically within each category. So in the case of batteries, for example, we have developed the capability and capacity to refine lithium, nickel, cobalt, copper. The next thing that we are doing there is getting into cathode active materials, which is what goes into your cells, lithium ion cells as an input. So as the gigafactories in India come online, we want to be ready to provide the raw materials that will go in. So these gigafactories don't directly consume lithium as such. So that is the idea here. And this is just one particular kind of product. The idea is to also see how we can make other kinds of value added products. They may be alloys, for example, meshes made out of nickel, plates, different kinds of value added products out of the battery materials that we have. Similarly, on the platinum group metal side, the idea is how do we produce these platinum group metals from different sources, whether those are secondary sources like spent catalytic converters or spent catalysts. Through them, we want to produce sponges of palladium, platinum, rhodium, and then produce value-added products like catalysts that can be used in, say, pharma or in green hydrogen industry. And Dr. Chidambaram, being an expert in this field, he'll talk a lot more about what specifically we are researching. And then the third category we are interested in is rare earths, where the idea is how we can produce rare earth oxides and then mixed as well as separated rare earth oxides, especially for neodymium, samarium, and praseodymium, which are magnetic materials, and then go a step further and produce value-added products, which in the form of magnets, for example. And then over time, we would also like to get into heavier rare earths. So that is broadly the set of areas that we operate in. We are also interested in critical minerals generally. So if there is any interesting research happening, whether on the product side or on the process side, we would be happy to engage in that. At this point of time, we have established a fair bit of scale. We have one of India's largest, we have India's largest lithium refineries and one of the largest outside China globally. And similarly for cobalt as well, we have India's largest refinery. Overall, there's a significant capacity that we have and significant scale up that we are planning to do. And all of this will require a lot of effort on the process improvement as well as on developing newer products. In terms of customers, we work with almost every major company in the country, all the main OEMs on the four-wheeler, two-wheeler side, on consumer electronics, metals, even finance and insurance companies. When they provide insurance to, say, EV companies, we help them out with providing value to them. Our key USPs, three main things. One is on the like our technology know-how, our operational know-how, and our team. On the tech front, we have a very interdisciplinary approach. And at this point, I would like Dr. Chidambaram to step in and talk a bit about how we look at research and technology.
Yeah, sure. Thank you, Pratish, and thank you, Amity.
Yeah.
This is fine. Yeah, this is fine. Yeah. So thank you, Amity, and yeah, I would like to say sorry to Madam Gaur, because I really bothered her before we come here. Right, since last 3 months, she was behind me to fix this meeting. But unfortunately, because of both of our diverse travels, we couldn't make it. So today I'm here. So I'm extremely sorry for getting it delayed. Having said that, so I'm delighted to, see your presentation. You people are working in a vast area. And I'm really happy. A private university having this much thought, that itself a huge, it's a remarkable achievement what you people have, achieved and trying to achieve more. So hats up to that. And so when we talk about LOHUM's technology R&D, right? Because our founder, he was, I mean, I would say he was a very, I mean, bossy guy. He didn't just start a startup. So he had a very thorough understanding of what he wanted to do. That's why when he thought about R&D, so any R&D person, right? Because first, by the way, he's not a chemical guy, he's an aeronautics engineer, right? With that background, he ventured into this chemical business with a thorough understanding, thorough idea. So when we put up the R&D, he thought I should have end-to-end facilitator within my R&D. I should not go around to get a solution for my problem, right? That is why when you talk about this battery recycling R&D first, every branch which is needed to do that business 100%, he ended up having everything. So we have 5 branches of R&D which will take care of the entire battery recycling, and today within that 5 branch of R&D we can take care of, as sir said, all the 30 critical mineral research. That's the strength. So what are those 5 R&D wings? We have a cell R&D, a battery R&D, or we call it mobility R&D. We have a software R&D. We have a commodity R&D and a materials R&D. What does the cell R&D does? When a end up like battery comes, it tests and it tells, as Pratish was telling, whether that battery pack is going to go for a repurposing or it will go for a recycling, right? Because if a cell has some life left over, we should definitely try to make use of it instead of just putting that into recycling, right? Though recycling is important, but again, you will be spending something and you will be using chemicals and all those things. So lot of battery we get, the battery packs we get with 50, 30, 40% life remaining. So we identify those cells, that is the job of the cell R&D, and they test the residual life, and then that is separated. That can go for the repurposing of the battery packs, which can go for any stationary application, not necessarily to the mobility application, but it can go for a stationary application. By doing that, we have already in Jharkhand and Chhattisgarh, we have already lightened up villages, libraries, public libraries and schools. So that is the one kind of activity. The second is the mobility. See, because once this cell R&D people tells what is the use of that particular thing, then the mobility comes and they take care of that new cell fabrication, the battery packing, putting the BMS, setting up your UPS system and everything. That is the job of the mobility R&D. And the software R&D, because when you do this research, because today, there are a lot of different kinds of cells and the lithium-ion battery cells are available. And you all are aware, almost India even buys the cells. Only the battery packing happens here, right? So the BMS is someone else, and you cannot have the control. So if I have to have a control over a period of time, I should understand the health of the battery, right? So for that, you have to have the battery management system of yours in that battery. So we have taken up that challenge. Now we have our own software team who develops all these things, components, and then we are in discussion with all the OEMs to put our BMS in the battery pack when they pack it before putting into their car, so that at the end of the life, even the owner of this battery pack will have a fair value when he goes to replace his battery pack or when he goes to sell his car. Today, what happens with the lithium lead acid batteries? So when we go with our car to change the battery, the shop guy just gives 250 rupees discount or 500 rupees discount to your existing battery and he takes it. Why? Because we don't have a data. We do not know what is the residual value of that battery, right? That's why whatever he gives or she gives, we simply accept it. But that should not be the case with the lithium-ion battery because it's already very expensive. You should know the value of your battery. That's why we are into that business to put our BMS in the battery pack. And we have a commodity R&D, as I said. What happens globally day in and day out in our field? It's very, very important. we have almost 80 scientists in our department R&D, but there is a dedicated team. That team does the global research, what has happened in that particular field every day. The night, 11 o'clock, we receive email from that team, what has happened globally on that particular day. We are, because unless until you are on top of the development, what happens globally, it's very difficult to cope up. So the fifth R&D is the materials R&D, who takes care of the complete recycling business of the LOHUM, right? So what are the recycling, as Pratish already mentioned, lithium-ion batteries, yes, obviously, which is, I mean, even today, that's, you can call it our breadwinner for LOHUM, right? Apart from that, we have already ventured into precious metal recycling and the complete rare earth metal recycling. Because out of the 30 critical minerals, almost 12 are from the rare earth metals. Because they just clubbed as one, but 12 are from that one. So because today we import complete magnet. India imports 100% of the magnet. What we do, our motor manufacturer, what they do, they import the magnet bars, cut it and make the shape and then fabricate the motors. That's the only thing we're doing. What about precious metal? The platinum group metals, we import 100%. And these are all very, very expensive. After importing, what we do, we consume it, especially in catalytic converter and even the catalyst. We simply consume it and then we export for refining, which is another huge loss. So we lose on both sides. So that was our another core area where we can put some effort and find out solution. At least can we do the recycling, 100% recycling indigenous, so that whatever you purchase, it doesn't go back. So that is the another big area today in India today. There is no one who recycles the catalytic converter. And we have already developed a technology and we have already covered the IP on that. And we have already put our pilot plant in operation. Soon, a commercial plant is going to be, I mean, we are going to set up in Hyderabad. So, which is what I'm going to take care of that business, okay? And the final one is the rare earth metal, what I talked about, right? 100% import. And to now, there are few mines in India, I mean, identified. And one is that GMDC, right? The Gujarat metal, that developmental board. Even our founder was there last week. We signed an MOU with them because it's a huge facility, but without manpower. So we decided we will provide our manpower, we will provide our technical expertise, and we have signed an MOU. Soon they are going to, I mean, they are going to invest and we are going to do the work for them. So it will be a joint venture, and hill has been identified that has got a very decent, I mean, reserve of neodymium, praseodymium, and samarium. So that is our huge activity that which will take care, which we will start in another a month's time. So having said that, so we are open for of all these critical mineral space. If we, because we are very open, it's not today we are with these 30 critical minerals. Tomorrow, if we find some interesting aspect of beyond these critical minerals, we are open to that. Because our umbrella is very big. It's not that the way you do the research, the way you take care of the different aspects of the science, we are also open to that. So let's discuss and find out what are your interest and what are our interest. Whether there are a lot of scopes or minimal scopes to start the collaboration. And as you said already, we have a collaboration with Dr. Sandbach, right? Who is also Ramalinga Fellow, right? Yeah. So definitely we can explore and find out what are the opportunities available. Thank you.
And just to add to what Dr. Chidambaram said, in terms of the kind of engagements that we typically have with universities and what we can do. So one is that if there is already a technology that is at say TRL6 or TRL7, and we typically the way we evaluate technology is through this technology readiness level. So if you already have a technology which is at TRL6 or TRL7, we would be interested. So if there is a mapping of all the technologies, we would be happy to have a look to see if we can commercialize that technology. So that is one. The second is if there are startups that are being spun out of Amity, we are happy to see if, and they are in the area that we work in or solve any of the problems that we are working on. We are happy to look at it as an investment opportunity as well. So we have a team that looks at promising startups to invest in. The third is we can work with the university and maybe find the right collaborator, and basically then we can figure out what sort of resources each of the parties can bring in and work on some live projects that are relevant for us in the industry and see how we can scale those. And so like one of the projects we are working on is with Professor Shanbag. And similarly, we can also jointly apply for grants with different industry bodies, different government bodies to work on, especially on critical minerals, and then also value-added value-added materials made out of these.
Okay, thank you. Thank you, Dr. Pratyush and Dr. Chidambaram for wonderful, essay or thesis on your company and your vision, and again flagging the areas or the modalities through which we can work together. I think we have our additional Pro Vice Chancellor Academics, Dr. Sunil Khatri, online. First, we will have his comments.
Yeah.
Then we will throw it open to our faculty members. Over to Dr. Khatri.
Yeah, thank you, Dr. Singh. First of all, I would like to welcome our guest today. It was really a pleasure to listen your thoughts and what you are doing at LOHUM Industries, and definitely at university we are very focused in terms of industry collaboration, industry interactions. In fact, over the last 5 years, we have been very focusedly work on industry-driven and led programs and courses also. For example, we have an institution, I think because you would have heard the presentation by Dr. Singh, which has mentioned about the various aspects covered at university. So one of them is that industry-driven degree programs and industry-supported programs also. For example, with Tata Technologies partnership, we have AIT, where we are running programs in area of engineering and technologies. Then we have also with CII, logistic programs running with the RICS. UK, we are running a program. Then also we are running partnership programs where the students are going in those trainings for in those companies. We in universities have also introduced and integrated the apprenticeship also in many of our engineering and technology programs. So yes, it's a very high time now. If you see our national education policy also, it also talks about having apprenticeship as mandatory. In fact, last week also there is one more guideline which has come that we should see and ensure that how apprenticeship can be more effectively can be integrated and operationalized in terms of providing an ecosystem for our students in terms of support, in terms of various options at the university level also, and from the industry perspective. So it's a very high time, and definitely your visit today to the campus is going to contribute in a very big way of how we can work together, both broadly in terms of academics and research. Definitely research, you have been interacting, and we have members sitting there in person also and online also who are working in these areas, and definitely they can share with you that what all research possibilities are there and definitely to take it further. But from academic perspective also, we are also very keen to see that how we can take your experience and inputs to contribute, because we are having programs in area of clean energy, we are in environmental sciences, we are in applied physics, chemistry area. So we have a dedicated institution on applied sciences also. Our Honorable Founder President Sir has a very clear vision to provide the student the best of facility and ecosystem, and it cannot be without the constructive contribution and involvement of industry. So your visit is going to be very helpful today, and definitely we will look forward that to your ideas that how we can use your expertise both in terms of curriculum development, their delivery of the contents, and also in terms of trainings of the students. And definitely faculty research is already being discussed, and it is also of a very important area and facet for a university to focus on. So again, thank you for being here again, and definitely Harjinder is coordinating. So thank you, Harjinder. And today morning, Harjinder has told me that anyhow, we have to be there in part of its presentation. In fact, there is 2 presentation right now, online meetings going on with UP Higher Education Council. So 3 meetings going on parallelly, but she had made sure that, and I was parallelly listening everything and on one of a system of what you have said about LOHUM, and definitely very interesting aspects told by you. And we are looking forward that how we can take this partnership to something where it can be outcome driven and focus, the theme of the even today we call it as a focused discussion. So we look forward that how precisely we can get some outcomes from both the sides to benefit from these deliberations. And on behalf of our Honorable Founder President, our Honorable Chancellor, Dr. Atul Chauhan, and from the university, definitely we are thankful for you to visit to the campus. And Dr. Singh, very wonderful presentation as always. I had heard initially that you were given. In fact, that's why I had not mentioned many of the things which has been already covered in the presentation. So we look forward that to listen to you, that how in both aspects, academic as well as research, we can get your inputs and plan how we can get that contribution, and how we can also participate in contributing to your journey also in terms of excellence. Thank you for being here.
Thank you, Dr. Khatri. Thank you for sparing time. I understand you are busy with 3 parallel meetings. Thank you. I think we have online the main person who is driving our relationship with LOHUM and Ministry of Mines. I think over to Dr. Bhuvana. I think we will have your comments and just highlight how your project is going on, because I was going through the objective. It's a very good project. If we succeed, we would be able to, really mine or specifically absorb some of the critical minerals. Go ahead.
Yeah, thank you. Thank you for this opportunity. And most important, I think this grant would not have been possible without the support of LOHUM.
Yes.
So I'm very thankful for their trust in my research and interest in this area. And if to give a quick update is that, everything is going on track, because I now recently moved to Amity Bangalore campus. So I'm establishing my lab, and I think the next week I will be conducting interviews. I've got a couple of JRF applications, and hopefully we get a good candidate so I can get the work started. And if anybody still has any good JRF candidates in mind, please, I'm open, send me the resumes, and I'll be starting all the interviews next week. And yeah, I think once my lab is set up, which will be in another month or so, month or 2, and I think we'll be ready, and I will be in touch with Dr. Chidambaram to ask for certain samples so I can start the testing and we can initiate it at that state. And I look forward to further interactions in the future. So thank you for this opportunity, and I think I'll let others speak as well. Thank you.
Thank you, Dr. Bhuvana. I think we can request our esteemed faculty members, Madam Dr. Vedatri.
Everyone, I am Dr. Vedatri Molik, and
So I have also done my BTech and MTech in electrical engineering, and then I did my PhD from Germany in the field of electric vehicle battery management. And I am also currently working on the BMS, so how we can estimate the battery states, particularly the health of the battery, and how we can employ some AI techniques or some more advanced control techniques to estimate the battery health. And I am looking forward to some kind of maybe real-time data where we can give some actual road load conditions on the battery, because most of the batteries are experimental batteries and they have fixed tests, lab-based tests done on them. But in actual real world vehicle, the load conditions are completely varying. So I'm looking for some kind of experimental data which can, with which we can test the battery under real vehicle conditions. So that is my subject area.
Good afternoon, all of you. So myself, Dr. Nirmal Kumar.
Would you like to respond? Yeah, so no, that's a very good, thanks for bringing that. It's very interesting problem for us as well. We would also like to discuss how the problem can be framed because while we're looking at field data, a lot of times field data is not available. But what is available is a lot of batteries at the end of life at different conditions. So from at least a reuse perspective, one of the things that would be very interesting for us is without a lot of field data, we can have some field data, but without a lot of field data, but with a lot of end of life batteries, can we develop algorithms to estimate the state of health? So that would be a problem we would be interested in. And we can discuss separately offline what kind of data sets can be made available. I'll put you in touch with the team that works on this as well. So we also have one researcher who's did his PhD from actually Cornell, came back to India to work with us. So he looks at this problem statement. So more than happy to connect you with him.
So if I may have to understand what kind of tools you have it now here at Amity?
So I'm actually working mostly on the software because hardware we have labs, but they are mostly on conventional vehicles, not electric vehicles as such. So in my the prior lab where I was in Germany, they had only the battery.
But
So they were doing the different load tests on the battery with controllable loads and sources, and they tried to give different load conditions to the battery, but only the electrical part. Thermal again is something which I have not yet investigated, like how we can also have a thermal behavior of the battery. So based on those load conditions, we try to make some battery models and then estimate the future health of the battery based on those load conditions. But
so we would welcome you to come and see our facility and this testing. We have state-of-the-art testing facility already in place. So, madam,
Yeah.
take her visit.
Yeah.
So you are welcome
Sure.
to come see and discuss with what Pratish with that gentleman. Then we can take a bit, there are, I mean, mutual interest to take it to the next level. Definitely we would be interested.
absolutely, it will be my pleasure. Thank you.
Thank you.
Thank you.
Now, Dr. Nirmal.
Good afternoon, all of you. Myself, Dr. Nirmal Kumar. So I have done my PhD at IIT Kanpur in metallurgy and materials. And I'm specialized in basically a cryo milling, where I develop my cryo mill setup. Yes, cryo milling, where I have developed my own cryo mills, which capable to produce nanocrystalline material. Basically, I produce like nanocrystalline high entropy alloys, which well good working for catalysis and sensing. And recently I submitted 2 projects for lithium extraction by this cryo milling. By milling like a table salt or calcium carbonate, milling with this waste battery materials. So I'm looking forward. It's like I can visit you and I can submit some projects supported by LOHUM.
I think once we listen, then there would be some who you are able to directly connect, instantaneous connect. Some they may connect after visiting. So I think, Harjinder, what can be done after some time when we send the overall picture and there can be a visit because you are not far from there.
Right.
So then when they see your facility, they may come out with a new idea.
Understood.
Right. Over to Dr. Bansewal.
Hello everyone, myself Dr. Rupesh Kumar Basniwa. Here I'm working as an assistant professor and basically I'm microbiologist. Currently I'm working on wastewater based batteries. So we are generating enough power to light whole room. So that is our currently work. If you are interested, that we can talk about this.
Is that from the lithium batteries or from some other battery?
No. Actually, we have developed our own battery,
Your
which
own
is
battery.
yeah, we have developed our own battery, which is working on wastewater. Wastewater can be any type. It may be a Yamuna river wastewater or other type of waste.
Okay.
Yes.
And how do you generate? Is it through some chemical reaction or?
Yeah, actually, if you see the waste material is containing a lot of different metal ions. and ions are going to move opposite electrodes as per their charge. That is the basic principle of any battery. So the same thing is going to apply in this also.
But still, I'm not very clear about your research because
Actually,
wastewater is your
wastewater is
source, right?
wastewater we are
With
using.
lot of iron, right? Free
Yeah,
iron.
and we are using as an electrolyte.
Okay,
We are using as an electrolyte wastewater.
that's what. So you are
Yeah.
using wastewater as an electrolyte.
Right.
But your cathode and anode materials are
Yeah.
conventional
Different
materials,
material.
right?
Yes.
I think if you can visit his lab and
Yeah.
see, because they have demonstrated the proof of concept
Understood.
and they want to scale it up.
Scale it up.
So they are also looking for a partner
Mhm.
where some engineering work is needed. That's what I know, and see in what way if you can help or assist them.
Understood.
I think एक बारी visit
But
करा.
what kind of is what is your cathode material?
Actually, it is already patented.
Okay.
So
we are
IPR is
we
there.
can't able to disclose it,
Okay.
but I can show in our lab.
No,
So
sure. Yeah.
Yeah.
Okay.
Right. Dr. Saikat.
Myself, Dr. Saikat Datta. I'm from AICCRS, which is a chemistry department, one of the chemistry department and a very research-driven department in the campus. So we are total 7 faculties now, headed by Dr. Monalisa Mukherjee, started this department in 2016. So later, from 2019, few faculties joined and then started developing our areas. So I work in the area of electrochemistry since last 6 years and trying to develop several new directions in the area of electrochemistry, starting from supercaps to paired electrolysis to now we are focusing on sodium ion battery. So this sodium ion battery research was initiated in the beginning of 2024. And in collaboration with one of my potential collaborators, we are coming up with a few novel material for anode and cathode and designing coin cell sodium ion cells, and also now moving towards pouch cell sodium ion cells. So this is a core research where we design new materials and look at their various features, including full characterization to sodium ion storage performance mechanism and the performance analysis. This research has been limited to so far in coin cell systems. We are trying to now expand it to pouch cell systems. And meanwhile, in last 3 years, we have developed an electrochemical sensor and energy research lab in our department. And that lab is fully functional now, catering various directions of electrochemical research. However, now we are more focused on developing a battery research lab, advanced battery research lab in our department. We are looking for both government and industry funding for developing that lab. And the major focus will be on sodium battery and zinc air battery research that we are currently doing from this lab. So when I heard about LOHUM from Harjinder ji, and then I was trying to find out that what are the areas in which your organization is more focused in. So several things that I have seen, but at this moment, I don't know, maybe a one-to-one discussion or a little bit further discussion will help better to understand that where our expertise means the kind of work we do here from MIT, especially my lab, where we really fit in there in certain capacity. Like there are several things that your organization is involving in mineral and battery recycling research. So I think I would ask for your suggestion that or exchange certain information to find out how is there any way to connect this sodium and battery research, the cell configuration and the construction of new material. Is there any way to connect with one of the areas where you are interested in? This is something I would be very interested to find out from with having some more discussion with you.
Before I also want to flag one thing. We are at the university system. The professor is doing research. where he wants, and he is also open to undertake any research of his expertise. Let's say he is expert in synthetic chemistry. Now he is synthesizing a molecule. Tomorrow, if you say that, okay, no, gentlemen, I need B molecule, I will sponsor. He would not mind developing B, because as compared to other government R&D institutions, there it is put on them that this is the project, you have to work in this area. So now, taking his discussion at, if you feel that you are working R&D at 3RL level 4, 5, 6, if you want to have some, you want to seed some future R&D, or if you want to evaluate or find some solution, part solution of your bigger R&D canvas, you can outsource offshore research. You can give it to us. We have many faculty members, and we would not mind, but doing research for you and providing you the solutions or data or evaluation, anything that can also be thought of.
That's what Pratyush said, right? Because being a commercial company, right? So if we have to start any project from TRL 1, it will take a lot of time for us to still be commercialized, right? So we see this problem in two different and distinct ways. So if you have something with at TRL 5 or TRL 6, we are very much happy to take it up, so that maybe within another 6 months or 9 months time, I will be able to see TRL 9 put commercialization. That is one part. The second part is what doctor is doing, that it is like a TRL 1 or TRL 2. That, because truly speaking, we don't want to spend that much of time to start that kind of activity. In that case, we will be more than happy to sponsor that kind of project, so that the faculty from university will take from TRL 1 to TRL 4, and then we will get on to that and take it to TRL 9. So this is absolutely possible.
Okay, agreed. But a part is long-term investment.
That will happen. That because when we onboard your faculty from TRL 1, it is definitely go till TRL 9, right? Till we commercialize, that partnership, that collaboration has to be there.
Right.
It will be. Yeah.
Okay. I think we have Dr. Meenakshi. Over to you, Meenakshi.
Sir, first of all, I'm Dr. Meenakshi. I'm representing University Technology Transfer Office, in which I look after tech transfer and commercialization. I also look after TSD Funded Technology Enabling Center, where we help the inventors to increase the TRL levels. And so you have Mr. Pratyush has already spoken about the technologies at TRL 6, investment in startup, and the working on some live projects based on the industry problem statements, and the joint projects to be submitted to the funding agencies to come up with the value added projects. So out of these four, I would like to submit that you mentioned about TRL 5 and 6 technologies. And sir, as you are from IIT Kanpur and you are also from a higher education institution background. So, the common problem with which the education institutions are struggling with is the low TRL level of the technologies. You speak about IIT Kanpur, IIT Kharagpur, Delhi, Madras, anywhere. You will rarely find the technologies at TRL 5 and 6. Most of the technologies are at TRL 3 and 4 only, right? So here at Amity University also, most of our technologies are at TRL 3 and 4. Dr. Basniwal spoke about the electricity generation and wastewater management technology, which is based on the electrolysis process. You have recently understood the technology. This is at TRL 4. So this technology has been already transferred to an industry partner. This is a Pune-based industry partner. Here the gap is their R&D team was not able to scale up the technology. That is why the project not proceeded forward. So we are looking forward to LOHUM Industries. If they can consider this technology, after this meeting, Mr. Basniwal will take you to to his laboratory, and you can see the level of the technology. And we can see how we can collaborate with each other on this technology for taking it further. Primarily for further scaling up and then the subsequent commercialization. The second is another technology which is from his lab is the fly ash battery. Yeah, so there is a battery which is made up of the waste, which is fly ash. You can easily procure from NTPC, and using 2 drops of water only, you will get the light. So it is clean water-based battery, which is working with the help of fly ash. And another one is the wastewater management and electricity generation. So you, in both the cases, the water is there and the battery is there, right? And I'm also looking after the tech-based faculty startups. And we have another department which is being headed by Dr. Garima Agarwal under the guidance of Dr. Mike Murthy, who's looking after the faculty-based startups. So we will identify these startups of your interest area for the investment purpose. And you have spoken about your the problem statements. We can identify the faculties in alignment with your problem statements and can have the live projects. And on the other side, we can have the joint projects, again, in line with your problem statement to the funding agency. So that's my submission. Thank you.
Thank you, Dr. Meenakshi. Shukla, Group Captain Shukla, would you like to make any quick comment?
In which your founder has started working and looking at the future of EVs in India, I think it's going to take off in a big way. And you have seen that we are already working in this field. So I think there is a lot of scope of interacting and working together. So we'll look forward to concrete proposals from both the sides so that we can work on it. Thank you.
Thank you. Now we have some more faculty members online. I think, may I request Dr. Abha Kumari?
Yes.
Go ahead.
Yes. Good evening, everybody. And I'm sorry today I'm not available to discuss in person. I am not well, so I'm traveling for consultation. But I was very much willing to have discussion in person. And I want to propose a proposal on this development of biological technology for extraction of this copper, then lithium and aluminum, then cobalt from cathodic part of waste lithium battery.
Hello? Yeah.
Hello. Yes.
Yes, ma'am. Yeah. So thank you. Yeah. That's one of the very, very interesting fields. We are, I mean, very actively looking for it. Okay. So if you can,
Yes.
I mean, we can make a proposal and we can take it up forward. And one more thing, my question to everyone is there anyone working on the membrane technology for mineral separation? So we would be, I mean, we would be very much interested to take up that project as well.
Yeah, separation, that once we extract, that has to be separated. So membrane we can go, and I have done solvent extraction, then further electrowinning. So further we will get the pure metal, but we can look for the membrane also, so that can be explored.
Yeah, so if we can talk about this, I mean, very selective membrane extraction for the critical mineral separation, that will be, because so when we talk about that, primarily that rare earth elements, the separation is very, very tedious job. So I can enrich my rare earth mix oxides to 99% just like that. There is no problem at all. But after that, how do I separate those 5 to 7 elements? That's where a huge task is just in front of us. If we can, I mean, formalize a project on that, that would be a fantastic thing. I mean, contribution, just not to both of us, the entire India. It will be a great contribution.
Yeah, it cannot be done in one step. We have to merge several technology, and we can first separate a few metals which will precipitate and all, or which will interfere in next step, and then we can go for solvent extraction or electrowinning directly. So there are a possibility of several develop the integrated technology where we can extract simultaneously, we can separate out, and that is possible. I have done for several systems, so that's there is possibility.
Okay, thank you, Dr. Abha. May I go to Dr. Anil Arya? Dr. Anil, are you there? Okay. Let's now Dr. Khelraj Pandey. Dr. Pandey? No. Dr. Ambika Devi? Okay, if they join, we will take their comments.
Yeah.
I think now may I request Dr. B.K. Murthy, who is Dean Translational Research, for his comments.
Thank you very much. Good afternoon, to both of you. It's very good initiative. I'm first time, even though I'm staying in Delhi for the last 38 years, I'm first time I'm hearing about your company. And we were also from our ministry earlier time also will try to discuss with various companies for lithium ion batteries and recycling of that. At that time, we did not know much about your company, but we had set up a startup in IIT Madras, IIT Research Park. Professor Junjunwala has started that. So I was part of that when it was set up. One of the important thing that we'd like to know, some of the student startups earlier, they thought of idea of the charging of EV batteries. It takes a lot of 5 to 6 hours. So there was an idea that why can't we use the battery swapping for battery swapping, but people have talked about it, but it did not take off because of they were only using the QR code for the finding out the life of the battery, but that is not sufficient because how much they have used already, that we do not know, because some of the batteries, it may be the life span maybe around 2 years only old battery, but it was completely used up. It was wear and tear and other things which were there. So maybe BMS is one of the solution for that. We can connect some of the student startups if they wanted to use it, because this is one of the major component, which is cost component in the electric vehicle. If you're taking up, it is the highest, almost 40% or 40% cost will be there. So, and nowadays, most of the EV vehicles and hybrid vehicles are coming. Everybody is using the batteries in those vehicles, and it is very important now to have that. So the other important thing that you can think of is that finding out other material for the solar panels other than silicon. Silicon is one of the thing, but it's still getting the silicon is also very expensive, and most of the sources are from China. It's very difficult for us to get that. That is one more thing. One more important thing is the solar panels are being used, solar energy is being used for various purposes, and everybody is harvesting solar energy. So, I mean, there may be a chance that will come for recycling the solar panels, how we can do it. That also maybe you can think of some of the things that we can work it out. Then any other material other than lithium ion for the batteries, that sodium ion he is talking about, but other than that, even then that's also equally expensive. I don't think it is very cheap when compared to lithium ion. Sodium ion is also very expensive. So any other material which we can have a cost effective or affordable batteries for the EV vehicle, that is another area that we can think of. By taking all these things from clues that we have from our university, we have right from the basic research to the applied research up to TRL level 3 or 4 or something like that. So where most of the wide range of applications are there, we can have a collaboration with this. In addition to that, we can have some of the, being academic institution, we can have some of the skill development programs also, including we can start short-term courses for various manpower generation, for even for the floor shop management. So that also you require a lot of people that is to be trained for doing a lot of work in the lab. That is another important area that we can think of. And we can have some of the joint programs of some of the skill development programs for the industries, and some of the internships, some of the students can come there as an internship for 6 months program or something like that for your lab. And we can think of. So all these things, what I would suggest is from our side, if we can have an umbrella MOU with you, so that we can have a variety of bouquet of projects, either it could be TRL level 3 to 4 enhancing. And especially in India, most of the academic institutions, you will find most of the projects are at TRL level 3 or 4 only. Even sometimes they stop at TRL level 2 only, because most of them are interested in either publications or getting a patent, and after that their interest will lose because they may not get any AGPs. So unless otherwise there are programs sponsored by various funding agencies, then yes, they will try to involve it. So nowadays the funding agencies are also expecting that an industry partnership is important, so that the baton can be taken by the industry and then further take it to the final commercialization. That is very important. Commercialization from the university is very difficult. In any of the university in the across the country or across the globe, it is very difficult unless otherwise industry also comes forward. So right from the beginning, or maybe if you are involved in some of this, so maybe we can have an umbrella MOU and then have a discussion. And then for each of the project like we are talking about, we can have a separate agreement, or we can discuss how we can take it forward. So that could be one of the best approach. I think we can do it.
Okay, so I'll throw some light on all these things. So we'll start from the end towards what is why universities are not able to, go for the commercialization things, because I worked in Israel, right? So Israel being a small country, how did they develop to this extent? What was yes, there was a motivation because they wanted to have self-sustained development for the entire country to safeguard themselves, right? From the, predators. That was there. But the Israel university system is like that. Every university will have a separate autonomous wing which takes care of commercialization of all their technology. So that was the only reason how I was there just for 20 months. But within the 20 months, we just filed the patent, got it granted, Chinese patent, Israel patent, US patent, got it granted. In 9th month, they sold the technology to a company. So that kind of, unfortunately, in Indian system, it's missing. That vigorousness, that aggressiveness is missing. I think we need to play a role. The government has to play a role to bring such kind of setup. But I would suggest to Amity, since you have so many departments, create one more department, the commercialization department, which will take you, if you have it, I think they should put lot of efforts. They should put lot of efforts behind your professors, behind your researchers, go around, find out the universities, institutes, the private companies who are working in that field. I think that is the fantastic job to do. That will be the first thing. Yeah.
I think.
No,
yes, that is the first thing, because when there is an arm and a people with a lot of responsibility, this will happen. This is missing, unfortunately. And the second thing is that when you talk about that, are there any other metal or element which will perform better than lithium or sodium metal? That is the fantastic question, but that's a Nobel Prize research or Nobel Prize problem statement. So if somebody can think of it, definitely it's going to be a Nobel Prize winning task. And the third one, so the solar panels and the skill developments, right? We do. LOHUM Foundation does the skill development program, courses, certifications to the school children. We have that program, both privileged children as well as underprivileged children. We have both, but we bring them together. The privileged children and underprivileged children, they come together, take up the project. We give problems. So this is your problem. We just give a bicycle. We tell them that you build a battery for this. And we give all the raw materials. They study, they read, they get expert advice from us, experience from us, help from us. Then they build the battery for the bicycle. So this kind of skill development program is possible. We can even formalize this in the form of a course, in the form of a certification, right? Yeah. For them, for school children, just a simple certification is enough. But in your case, it can become a certification course, right? We will become a partner of it, and we will do that skill development activity. Your university can give a diploma. It can give a certificate, right?
That's a good idea. Even for some of the people who are using labor, class 4 employees use the cycle.
Yes.
Convert them into
battery enabled cycle. Yeah. Right. So these kind of opportunities are available.
I think, Harjinder, we can look into it, because we send our people for internship
Yes.
If they are interested, that can be extended it in such a way that it is formalized and they get some certificate by some government body that will carry a long heavy weight. Okay, we will, okay.
So on the internship front, so right now we get interns from multiple universities. So we have we get interns from IITs, from BITS, even from Shiv Nadar University here, and a bunch of other universities. We would be happy to connect you to our recruitment team on the internship front. Is there a 6-month internship also? Because we prefer if there can be a semester-long internship. Okay.
It can become the project, the final semester project.
You can, through that you can also choose, cherry pick the best talent.
Yes, so we can do that. Okay.
Okay.
So both for technical and
do
business
that. You
roles,
do.
we can look at that because we also have a lot of business people.
Almost all our interns, whoever comes, almost everyone is on board. Almost everyone is on
No,
board.
we also have this thing in mind.
So within that 6 months or 12 months, we make sure that that material becomes on board.
No. This internship is a very big win-win situation, win-win situation. Okay, I think we will do that and thanks for that. I think we have Ambika now. She's online. Ambika, are you there now?
Yes, sir. Yes, sir.
Okay, go ahead.
Good afternoon, sir. So, thank you for giving me this opportunity, sir. I'm Dr. Ambika. I'm working in MIT University, Gurgaon, as a professor and head of the physics department. So currently we are working on the supercapacitor materials, nanomaterials for the supercapacitor applications, which is very close to this battery and, making the devices. So we are exploring the nano composites for supercapacitor applications, and we are trying to enhance the power density and cyclic stability of the nanomaterials. Thank you, sir.
Okay, thank you, Dr. Ambika. I think now we come to Dr. Nidya Sharma, who had been listening very carefully each and everything, and now he will be concluding, I think, most important remarks. Okay,
Thank you, Dr. Singh. Thank you very much. I think today, I think is a very interesting discussion which took place, and it is on both sides. You also gave your ideas, your viewpoints, and various topics that we discussed, and you have listened to the researchers on this side. I will start by this upscaling the TRL. So what Dr. Murthy was mentioning, that we only get stuck at level 2 or maximum to level 3 in an academic situation, and this is what we thought in DST way back. And this is why the technology enabling centers were created. So we have one technology enabling center here. Meenakshi is heading that group. And the objective is precisely the same. So you have a technology which is stuck at level 2 or level even at ideation stage. Can we increase the level to, let's say, 3 or 4 or 5, where DST and other institutions can come and support with the participation of industry? So industry and academia together, such projects, then the role of TEC. I think this is a very important discussion from the point of view of TEC as well. Yes.
The government is there to provide the funds for increasing the TRL. Where we are lacking is the financial support from the industry side, because the Indian industry mostly they are risk averse. So they are ready to provide the in-kind support. But if we come to the financials, they step back. So this is the problem. I really request, as you are also.
It is an open request to you. Not to you, but to all.
Probably, I think Dr. Bhuvana's project, probably you have funded, right? So there is a fund which has come. So, yes.
Declare that there is an opportunity, provided there is a problem statement which will help us as well as the research.
Right. I think this industry I've seen, like the previous industry which had come to us, and this is a very open industry. This is an open industry in terms of research. What Dr. Chidambaram mentioned, that he is open. If you have some good ideas, they also talked about beyond critical minerals. It's not just critical minerals that they said. Beyond it, if you have something to offer to them. And Dr. Bhuvana Shanbag's research, which is already funded by them. So it is not just equipment or that. So they are funding it, and there are possibility of many more such funds. I think I would like to go back to the Government of India's critical mineral mission, which is they're focusing on 30 such minerals. And of course, they have also announced some incentive schemes for exploration. I mean, from exploration to beneficiation till the end, end to end. So they want to see that our role, and it is not in India they're looking for these critical minerals. They're looking these minerals abroad. So they have created a company which is known as Khanij Bidesh India Limited, Kabil. Now, Kabil is a company which is created by CPSEs, the Central, Public Sector Enterprises. 3 or 4, I think, of them together, they brought in and they created this kind of a setup. Whose objective is this? And they are also supporting the Government of India, the Ministry of Mines supporting, and the number of projects. In fact, the GSI, which is the main body to do the exploration part in India, their exploration in the critical area, critical minerals domain have increased from 59 in 2021 to 122 in 23-24. So this is a huge, from the Government of India. I think we should use this opportunity. We should take advantage of this opportunity. I think you have described very aptly and very nicely that you have 5 sort of verticals, but they're connected to each other. So basically you are into lithium-ion battery recycling. And whenever a battery comes to you, so you start looking at it and then see what is the actually the life left in this. Then you see how can this battery health can be predicted, the software part of things and so on. And then you also have a team which works and looks the global scenario. What is happening in this research in this particular domain? This is very interesting, part of business. It's just not that you're doing something and you're happy with it. You're also trying to understand. Exactly. The world is moving. Yeah. So we lost many such opportunities in past in India. We lost in computing and so on, so on. Many things we lost in the past. And then, of course, the minerals R&D. You're also focusing on that. I think some of the topics which emerged out of this discussion, I think some discussion which happened is basically focused on the battery health management systems. This is very important, I do not know, I'm not sure about as a user. Nowadays, whatever software that we get in our cars or our vehicles, do they, in some sense, they give you some kind of an indication that your battery's health is lowering down. So from a very sparkling light, a dim light will happen in the batteries, when these batteries show. So that means there are software which are checking constantly in a vehicle. Probably I may not be aware about it, but is it there or not? So it is there. So it is there. So they immediately, when you start your car, you come to know that your battery's health is, declining. This is also happening, in remotes. If you start the remotes these days, in the TV screen, you see that your remote battery is, weak. So the time has come to replace. So there are some sensors of these kinds available, but there is a research which is required at our level, at the consumer's level, where we can know for sure that this is the battery health, as you said, 30 to 50%, when they come to you, 50% is too much of a life available, and then we lose. I go and change my battery of my vehicle just by a hunch or a guess. क्या बदलना चाहिए मेरे को 3 years हो गए हैं, but it is not necessary कि 3 years के बाद उसका life 2 years और भी हो सकता है. Anyway, the second part was, I think you were keen on the wastewater electricity generation, which is a project, which is going on. And the other part, I think Dr. Datta was mentioning about the cell and battery research kind of work which he is undertaking in this. So there are many things that we discussed, and probably you would find something very useful here once you visit these labs, once you visit them, talk to the researchers over there, see the facilities, what can be done, what cannot be done. It is not necessary that what we talk here may not be, to that laboratory level. You see that you can suggest, So with that, I think I would like to stop here. And again, thank both of you for coming here, talking to us, discussing with this university. You've seen the vastness of this university in terms of research, course, curriculum, many things which can come out. I think Dr. Murthy has already summarized. There are some programs, curriculum, certificate programs, internships, and maybe some PhD topics that you may not be interested in taking up yourself, but you can pass it on to some of the university. And Dr. Singh also mentioned that private universities have a distinct advantage compared to, so there are pluses and there are minuses. So when you look at the pluses, you should, I think, reap on the harvest from that, pluses on. Thank you very much. Thank you, Dr. Singh.
Thank you. Thank you.
So maybe this is the right time where we can, some of our scientists and academicians, they will come to your lab and then visit that. We can jot down 10 or 15 problem statements. Okay, then based on that, we will find out who can fund it, whether you can fund it, or we will find out some collaborative proposal, R&D proposal we'll submit. And we'll create a database of all the problem statements in this area, because this is one of the upcoming area and many people would like to work on it. If not you wanted to work, maybe we'll work with somebody else or maybe some other thing. It is for the benefit of the nation. Then we'll work it. So this is very, very important, and semiconductor mission is also being started. And some of these materials are very, very important. So that is where we need to work out. So as a first step, maybe we can have an MOU. And second, we'll visit some of the people to your lab and we'll sit down, have a brainstorming, jot down some of the 10, 15 problems which are interest to both of us. Thank you.
Okay, I think, thank you. Would you like to make any statement at the end?
So from our side, we would like to thank the university for being such great hosts. We did not expect it to be so well organized, because usually we just go and look at the labs, but it was very, very well organized. So I would like to congratulate the team on that. And it was a very comprehensive session. We got to understand broadly the areas that the university is working on. We would love to continue the engagement and understand, host the faculty at our facility, understand it, have you interact with our researchers as well, maybe over lunch or something. And then maybe we can list down the problem statements that we have and see which of the problem statements can probably be taken up by the university.
Yeah, sure.
Thank you, Pratyush. Now I think again I'll come back the outcome. Now the work starts now. Harjinder, now I think if I have to just say the action points, compile the title topic of our faculty. Also seek the problem statement if they have any, which Dr. Pratyush is saying. Plan and this title topic, so that once we have the common title or topic, we can take it ahead for joint project, etc., etc. Then plan a visit of interested faculty to their, facility. Also, they will connect with their HR for internship, and also work out how we can extend the internship for the certificate course or diploma course, with our university functionaries. And I think we will work with them for a long-term partnership. I think the vision is that we would like to have a center of excellence with you along with Ministry of Mines. I think that should be our goal. Thank you very much. And I think today's team was led by Harjinder Kaur, helped by Kavita, Parul, Koshki, Vidhi, Vivek, Ruchi, and Upreti. Actually, they are the S&T warriors. They work on a mission mode. And this nomenclature has been given by Honorable Founder President. You come from Israel, everyone has to undergo a military training. And that's why there is one management course. And they complete the 2-year job in 1 year. So they are the S&T warriors of MIT. Thank you. I think let's clap for Pratyush and okay. The last, I think we would like to, felicitate you. Visit. Neeraj, I think more. I think everyone can. Okay.
You guys are very good. I must say that.
Meenakshi, come.
I think we have a group picture where this is.
Let's have a group picture.
Yeah.
Scientists, please join. Come, all of you, come. And madam, I think your project is very well fitting into their. They should be right here.
Thank you.
अभी आए
Cycle.
This side is at some place.
the guys who are going to take it
I hope
forward.
you got some visible है ना वाले हैं
Okay, thank you very much for capturing all of us and transmitting it. Thank you.
So now we have planned your couple of Miss Kavita ji, you met her already. So she will be accompanying both of you and then further she will take care of. Okay.
Quickly.
That's okay. Yeah, one more. No, they clap, see.
Harjinder? Yeah, I just want to say thank you for this opportunity and thank you everybody. Thank you Pratyush, thank you Dr. Chidambaram, and I'll keep in touch with you. I also have going now, and I hope you enjoy your visit at Amity Noida and looking at the labs. And very soon I'd like to invite you to Bangalore once my lab is ready as well. And we'll keep in touch. Thank you very much.
Thank you, Dr. Shubhana.
See you. Bye-bye.
Is that current?